The best way to learn PLC programming is by practice. Now, I can imagine that you don't have an access to a real machine, but it's not a problem because we have factory I/O. I will show you how to configure factory I/O to work with PLC or PLCSIM, and then we will write our first program that actually controls something. Okay, so first thing I'm doing, I'm opening the factory I/O. I want to use one of the existing scenes. I don't want to start everything from the scratch because it's some work. We don't need to do that. So I want to use the simplest scene we have here. But what I want to do, I want to add an operators panel. I'm going to select this thing, place it somewhere here, and also this thing. And I want to put only two buttons here. I don't want to make it too complicated yet. I'm just going to put a start and stop button. So I've got the start button here and a stop button. All right, what we see right here in the left top corner, all the tags that we're going to use in this application. So we have conveyor. It will be an output from the PLC. When we make it on, it's going to move this crate forward. It's a sensor. We've got the sensor here. It's going to sense when the crate is at the end of the conveyor. We have the start button, the one that I've just added here. Start button light, which is a light of this button. Stop button and stop button light. So the next thing that I want to do, I want to create a new project in TIA portal, and I want to create a connection between a PLC and factory I/O. I'm adding a new device. And of course, it's going to be the PLC that I am using. And what's very important here is the hardware configuration. I'm going to start with the Ethernet address. So the Ethernet address that we're using here is 192.168.0.1. You can remember it. You will need it after this. You can always check it here as well. Just have it in your mind that it's important. Next thing that I want to take care about is I/O addresses. So these addresses here are the I/O addresses of the physical inputs and outputs that I have on this PLC. So right now they're starting from I0.0 and Q0.0. And factory I/O can use different ranges of addresses, but we would have to make a change there. I prefer to make a change in TIA portal and then use addresses starting from 0 in factory I/O, because we don't want the physical inputs and outputs overlap with inputs and outputs coming from the factory I/O. I'm going to change it here. I'm going to make the physical inputs and outputs starting from address I32.0 and Q32.0. And that's it. Just to verify, analog inputs start from address 64. We're all good here. Next thing I want to do, something I do every time, I want to enable the use of system memory byte and enable the use of clock memory byte, because I like to use these signals. And the last thing we have to change here, or make sure that it's here, is we want to select this full access option. It will be selected by default, but if you were using this configuration before, you might want to make sure that it's going to be full access. And also, the next setting, permit access with put get communication from remote partner. It's very important to select it, otherwise factory I/O wouldn't be able to communicate with our PLC. Our hardware configuration is done, so Now let's save it and make a download to the PLC. So let's check if the PLC is running. Okay, so the PLC is in the run mode. So now let's go to Factory I/O and set it up to work with our PLC. So I'm going to File, Drivers, and I've tried it before. So this driver is already selected, Siemens S7-1200 1500. And I want to go to Configuration, and I want to make sure that the right model is selected, so S7-1200. The host is 192.168.0.1. This is the address of my PLC, so the one I've shown you before. If in your case the address of the PLC is different, then you want to make sure that they will match in this place. And network adapter, I'm using this one, Ethernet connection. And now I/O points. Remember I told you about the addresses? So we've got the offset here. So we could move the addresses that Factory I/O is going to use, but since I've changed it in the PLC hardware configuration, I don't need to change it here anymore. And the addresses that Factory I/O is going to use will be starting from I0.0 and Q0.0, and count the number of inputs and outputs that we're going to use. 2 is not enough, obviously, so I'm going to use 8, both for inputs and outputs. I don't need more at the moment. 8 inputs and 8 outputs is actually a very small system, just so that you know. I've been usually working on projects with around 1000 IOs. It's a middle-sized project. Let's go back to this place. All right, it didn't work at first. It worked after I tried for the second time, so all the configuration was proper. Something just didn't work properly. So if something is not working at first, just don't panic, try it again. Sometimes you need to restart your computer. It's funny because I've had a situation myself a few years ago, and then I learned, and a lot of my colleagues had similar situation that they've been struggling with a problem, and all that had to be done is restart the computer. And so sometimes it's just like this. So this green check mark here means that we have a connection and we could start working with the machine already. But before I do that, I want to show you how to make a connection between PLCSIM and Factory I/O. And now I'm going to go to the website of Factory I/O. What I want to do, I want to go to this section, setting up S7 PLCSIM version 13, 14, 15. I want to download one of these faceplates. If you want to work with S7 1200, then 1200. If you want to work with S7 1500, then S7 1500. S7 1500 is much more powerful PLC, but for learning, I think S7 1200 is just what you need. So I'm downloading this guy and I want to extract it in automation. All right, so now I want to open this project in TIA portal. Okay, I'm going to browse, automation, and I'm going to use this template. It's closing the previous project, the one with the real PLC, and it's opening the template that's been already prepared for you to work with Factory I/O in TIA portal. So pretty much everything is ready here. The device configuration has been done for you. You don't really need to change anything. So all you need to do is start the simulation, make a download. Let's switch this PLCSIM to run mode. And the next thing that you want to do, you want to go back to your scene. Let's minimize this one. And let's change the driver. So let's change the driver to Siemens S7 PLC SIM. Let's go to configuration again, and everything is selected properly. The only thing that I want to do, I want to change the number of addresses that we're going to use, and let's try to establish the connection. And it's working. So we've got the connection. Now we can start the programming. So the only difference that we're going to have now while programming for PLCSIM versus programming for a real PLC is that we need to keep in our project this FC here, FC 9000, and also we have to keep it here in OB1. It has to stay there, so when you start programming, you will have to start programming from network 2. You cannot delete this block, it just has to stay here. Besides that, everything is going to work just the same. Now let's get to work. Let's actually start to do some programming and try to control this conveyor. Now let's start some programming. I want to go back to my original program because I want to use the real PLC. I don't want to use PLCSIM anymore. I think you know enough already and you know how to use it. Maybe I will make one more example, but from now on everything is going to be the same, both if you're working with an actual PLC or if you're working with PLCSIM. Okay, so the first thing that I want to do, I want to create an IO list with PLC tags. I want to have something like a list with inputs and outputs. So we have this section here, PLC tags. I've shown you PLC tags before. And we want all the inputs and all the outputs listed here. Some people create separate lists for inputs and outputs. I don't do that personally. It's a matter of personal preference, or maybe some customers require that. In my case, I'm just using one common tag list for all inputs, outputs, and memory flags, if I use memory flags. I don't do that too much. Let's go back to factory IO, and the only thing that we have here is the sensor and factory IO running. So whenever factory IO will be running, we can get this information inside of the PLC. But I like to change the order a little bit. So I want the sensor to come at I0.1, and I want the start button on I0.2 and stop button at I0.3. And now the outputs, we have only conveyor here, but since I've added an operator panel and we've got two push buttons with illumination, we will have the start button light and stop button light, and I'm going to use it at some point. One thing you might have noticed and you might be wondering about, the sensor is light green, start button is dark green, and stop button is light green again. Why is it so? In industry, you want to have your application as reliable as possible. So that's why very often sensors, if they are sensing something, well, it all depends on the application, what you need it for. But very often they will have normally closed contacts, which means if they do not detect anything, you will get a signal coming to the PLC. If they're detecting, then the signal is going to disappear. The reason why is because if the sensor is broken or if there's some issue with the cable, you want to be sure that, okay, this sensor might be detecting something, be careful. Same for the stop button. When stop button is not pressed, this is when we're getting a signal, a high signal, because if someone presses it, the signal disappears. But also, if the cable is damaged, for example, the machine is always or almost always in safer state if it's not moving, right? So we want stop button on normally closed contacts. So that's it. And now we have to recreate it in the PLC. The normal way I'm used to do it is that we have a drawing which is made by a designer of the system. So we have all the electrical connections there. Based on this drawing, we're generating an IO list, and it's usually an Excel with all the inputs and all the outputs. And from this Excel, we can generate a file that can be imported into TIA portal. Or in this case, it's only few inputs and outputs, so I'm going to just do it manually. So what I'm going to do, I'm going to type it here. And the address is I0.0. We have the proper addresses here, but I need to change the tag names. The IO list is ready now, but I want to check if everything is actually working properly. So I'm going to make a connection to the PLC. And after I make the connection to the PLC, I will make so-called IO check. IO check is actually a very important part of commissioning. This is one of the first things we do when we get to the plant and when we start to commission the system. So what is an IO check? IO check is checking every input and output one by one and see if they work. What we can do, I can create a watch table. In this watch table, I'm copying from inputs from PLC tags to the watch table, and now I'm going to start to monitor it. But first, what I want to do, I want to download everything to the PLC. Now I'm going online. Now I'm able to watch all the values. What I'm going to do next, I'm pressing the play button and press the start button. So when I press the button, notice that the state is changing here. The state is changing here while pressing the start button. And now I will press the stop button and same thing should happen here. So I press the button. All right, it's working. I would like to check the sensor, and it's very often the case. You need to actually run some little experiment, so to say, to check some sensor. To check the sensor, I will try to move the crate that I have here, to the end of this conveyor. So to do that, I need to force something, to force the conveyor to move. I actually need to check the outputs as well. Address Q0.0 will not be forced with value true because the corresponding peripheral module either does not exist or there is more than one peripheral module. This means what I want to do, I want to force the value of the output, but the output is not assigned because there is no hardware in hardware configuration that has this address. So seems like the force table is not going to work in this case. So if we cannot do it like this, we have to try some other ways. We have a possibility of forcing stuff inside of factory IO. Well, it's not as good for IO check, but we have to do it like this because we're not working with a real object, we're working with PLCSIM. So what I'm going to do, I'm going to force the conveyor to work and move the crate to the end of the conveyor. And I want to stop it for a second. Let's go to the watch table. And now please observe this sensor. So the signal disappeared. Once the crate entered the sensor area, the signal disappeared. So now I will move the crate a little bit more so that it falls from the conveyor and the signal should come again. See? So I moved the crate a bit farther, it fell from the conveyor, and now we get the signal here. This means that all the input are wired correctly. So now we can get to programming, because we actually don't have a possibility to check the outputs in the way that it would usually be done. We can use some different methods, like we can write a program that would allow to do that. But to be honest, it's not the way it's usually done, so I'm not going to do it now. Let's think what's going to be in a program. The application that I would like to write and I would like to show you is this. We need the conveyor to transport the crate forward after we press the start button. So we press the start button, the crate starts to go forward. And it goes forward as long as we don't press the stop button, or until it reaches the sensor. That's a very simple program, and you will see how it works. First thing, I will add one more network, and I will start from network 2. Let's add the coil, and this coil will be the output, the conveyor. Conveyor forward. And conveyor will be going forward when we give it a command to go forward. So let's create a memory flag that will say, now this is a command to go forward. I'm going to go to PLC tags, and I'm going to add a flag here, and it's going to say conveyor forward command. Well, you will be using a lot of tags in your program, okay? Especially if the application is a bit bigger, then you'll use a lot of tags, and there's no way you're going to remember all of them unless you're a genius, like a real genius. You're going to use the comment here. It's very smart to use them. Sometimes you might come across someone else's code that someone doesn't use comments, and reading this code and troubleshooting it is a nightmare. So don't be that guy. Use comments. It's very simple. It might be time consuming at first, and it might be painful at first, but it will save you a lot of time in the future. In this case, the name of the tag says a lot, but sometimes it's difficult to convey the entire information description of what it's doing inside of the name. Let's split it and place it here. So now, where do we get this command from? I like to have one network up always, then it's easier to add one above again. In the end, I can delete one in the top. Also, one more thing that I always do, or I always try to do, is to give the name of the network. Because if you write long programs, then you want to find something in the code, and the best way to do it, if you have comments of the networks, you collapse all the networks and you just look at these comments here. So for example, you just open this network and see the logic behind conveyor forward output. Next thing, we want to know when are we going to give the command. So whenever there is a command, the signal will come from here through this contact to conveyor forward, and it will go forward. But now the command, I press Ctrl and drag and drop, and it copies the thing. The conveyor forward command, I will write the simplest program to give you some intuition how it should work. So first thing, okay, so now when we press the start button, it should go forward. Let's compile and download this program and see how it's going to behave. Download device, software, all the changes. There's an easy way to start from the beginning. Just press this one and this button again. There we go. So what's happening now? Let's also watch the code, because it's really nice. You have a possibility of watching the code and watching what's happening. So I'm pressing the button now. Okay, so whenever I press the button, the command goes through this contact and activates this coil. And whenever this coil is activated, it allows closing this contact and give the command forward to the conveyor. That's the simplest program. But well, do we want to keep the button pressed every time we want the conveyor to go forward? Well, no. Well, we don't want a purely manual operation. What we could do, we could start the conveyor after pressing the start button and stop the conveyor after pressing the stop button. Okay, so let's try to do this. What do we need to give the command? We need the start button pressed, and we need the stop button not pressed. Remember, the stop button has normally closed contact. So whenever it's not pressed, it will be passing the signal. Whenever we press it, it will not allow the forward command. So it's like this. So what's going to happen when we press the start button? When we press the start button, the signal is going to go all the way through and activate this latch. But what happens if we release this button? Well, this becomes 0 again, and the signal is going to disappear, so the command is going to disappear, and the conveyor is going to stop immediately. So what I'm going to do, I'm going to use this command here to know, okay, you're running now, so keep running until the stop button comes. So whenever the start button is pressed or the forward command is there, keep the forward command. Let's try it out. Download to device, software, only changes, and we'll see how it's working. We see the code, try it again. See, whenever I press the stop button, these contacts here become blue instead of green, which means they're disconnected. Let's reset here and look. See, we only had the start button coming for a fraction of a second, but after we've activated this coil here, this is already 1. So the signal is passed this way. So it's going to be sustaining itself until the stop button is pressed. Let's see it again. See, this is the basic set reset function. We set on start button, we reset by pressing stop button. After the crate gets to the end of the conveyor, okay, so the crate got to the end of the conveyor and it fell. It seems like the behavior that we don't want. Let's use the sensor to stop the crate from falling. Let's add another contact here and see what happens. See if it works properly. Let's see if the crate is going to stop at the end of the conveyor. Let's make a download. Okay, see, it's still working the same. But now the crate got to the end of the conveyor, so it's not going to go anymore. Well, we can add some manual operation. For example, if we press the start button now, it will go farther as long as we press the start button to give the operator more flexibility. We can do that. It's very simple. Whenever the sensor is not activated or or the start button is pressed, it's going to go forward. Okay. So now we can push it a bit farther, even though the sensor is covered. See? So the signal can find its way to activate the conveyor forward command. Alright, and now it fell. One more thing, we have illuminated push buttons. And they're very important because they're able to show the operator the state of the machine, even if he doesn't see the machine or see exactly what's happening there. So lamps are a great, simple indication for an operator, and they're used a lot in industry. Let's add another network. Start lamp. We want a very similar thing for the stop button lamp. We've got a new thing here. This is normally closed contact. So whenever the signal is 0, this is going to pass the signal through, and whenever it's 1, it's not going to pass. So it's working just the other way around as this one. Here's what I told you before. You collapse all the networks and you can see what is in each network, and it's very helpful. Use these comments, they're there for you and other programmers who are going to work with your program after you, so please use them. It's a very good practice. So download the device. So now what we have here, this lamp is now on. See? Because conveyor forward command is not there, that's why stop button light is on. Okay, we're using different kind of contacts here. Now this lamp is obviously off because the conveyor forward command is not there. Let's change the situation a little bit. And this lamp is on. This lamp is off. This is our first program with Factory.io. I hope you had fun, because it's fun for me actually. It's something really simple, but it's a lot of fun for me. So I hope you had fun, and I hope to see you in the next video, or you see me in the next video. And join the Facebook group whenever you have any problems. Ask a question in this Facebook group. I'm going to try to answer, or other users, I hope you're going to try to support each other too. Well, see you guys in the next video.